Welcome back to another video for the Linux series. In this video, I'll be going over managing processes in Linux. Now, I'm going to do just a few exercises, nothing too much. For the first exercise, I'm going to find a runaway process in Linux. Now, a runaway process enters a usually a never-ending loop and can create new processes. Now, hence, these processes must be located before it causes any sort of resource exhaustion. All right. I'll be using a couple of different tools within Linux to help isolate and identify these, right? Like CPU performances, memory, disk performances, things of that nature, right? So let's get started with the first command to take a look into these sorts of things that can happen. So let's start with this one, right? Should be in. So what I'm doing is simulating a CPU intensive application with this command, and the MD5 sum, it'll generate a hashed value of the entire disk once it's once this command runs. Actually, you know what? I'll just go for another tab while that's running background, right? So actually, while that's doing that, I'll get started over here. So let's do top, right? And it's giving me a list of all the active processes running in the Linux system. Now, in this terminal window, in the last column for an MD5 sum, right, it's at the top. You can take a look at the CPU percentage, right, that it's using, right? And it shows pretty close to 100, which is not ideal. Though this is temporary in this situation, a true runaway process would degrade performance. Now, in the, let's see, the user column, right, I can view all the processes from all user accounts as well. Now, now what I'm going to do is actually go back to here, right, and it should be a hash value that generates. Let's see. It's like it's taking a while to do that. But there should be a hash value that does generate, and then it should take me back to the terminal. Right. Nonetheless, that's fine. I'll just go to system monitor so we can take a look, see what's going on with our system here. Okay. So it went down quite a bit to the low 20s range, right? And what System Monitor is, for anyone that doesn't know, it's a graphical user interface utility that displays some of the same information shown with the top command that you would enter in the Linux CLI, right? And a default setting usually only shows the processes run by the currently logged in user, which is why it changes to all processes versus just one of a certain kind. But nonetheless, it just displays all the processes that are currently running. So I'm just going to go back. I'm just going to minimize this and go back here. Oh, there it is. There's the hash that I was originally looking for. It finally showed. But nonetheless, I'm just going to do it again. Let's see. Sudo d5 sum, get the hash. Okay. That's for a password. Okay. So now take a look at the monitor. Let's see. should give me some additional, some other things going on here. Let's see. Yeah, something's going on, but it's not. Let's see. Okay, I see. Unattended upgrade versus them defined some. Let's see. Yeah, that's quite a bit of CPU usage. Let's see. Hmm. Now, for some reason, I'm noticing that the CPU value here is different from the one reported in the top command in the terminal. Let me just close this out. Yeah, let's close the window. All right, perfect. Now I understand that the top command shows the value of a single core CPU usage, while the system monitor accounts for the dual core CPU usage. So what I'm going to do now, take a look at identifying memory performance usage, or performance hits, right? So applications typically, or processes need access to memory to function, right? Now, when they're complete with the task, some applications sometimes may not release the memory back or the RAM, right? Those applications may continue to require more memory, which can cause increase in memory utilization to the point of exhaustion. Now, ultimately leaving a little memory and causing performance issues for users. So what I'm going to do is identify the memory performance in a Linux system, and I'm also going to use free and top commands to view the key indicators of the memory exhaustion. So now that I'm back here in the Linux terminal, let's take a look here. All right, so the memory allocated values that it shows here it looks pretty decent. And now what the free command does is just displays how the memory is being allocated by the system. All right, so you have your mem here, which is the physical memory. All right, and then pretty much everything, the share, the free, the buff, right? Memory used by the TMPF file system and things of that nature, right? Now, just let's see, I'm gonna open another tab here. And I'm gonna do pretty much what I did before. Hash value 5 sum. Okay. Now the command should be running at the moment, so I'm going to navigate back here and then do it again. Let's see. There was looks like there was a minor change between used and free. It's like a buff and cache. Let me try it again now that it ran for a little bit more. It looks like an increase for the used memory and a decrease for the free memory, naturally, right? All right. All right, perfect. So the availability, from what we can see now from me running the command twice, the available memory is now less. And maybe sometimes just for a few seconds or more, but the program is currently running and using some of the available memory. Soon it is going to recover. Now, in the application that's typically leaking memory, that available memory may continue to become less over time as the application doesn't let the memory release back into the pool. And I may run the free command a few more times before I can see the change again. Yep, there it is. It's still steadily decreasing. Let me clear this up. All right. And I'm actually going to close this out so it doesn't run anymore. Yeah, and then I'll just keep this one open. So now lastly, what I'm going to do, at least for this exercise, I'm going to identify some disk performance hits. Now, typically, right, files could take up space, right? So it's necessary to know the location of the files in the system. Locate Locating these files can become the starting point in like troubleshooting storage exhaustion. So what I'm going to do is identify how disk utilization is normally shown in a Linux system. So as you can see, I just used, I'm going to use the du command to view the disk utilization and isolate some disk issues. I'm going to start off with the df command, which displayed the file systems and the disk usage. So now that I see that, I'm going to use the du, as I mentioned, and let's see that one. Looks like we're the administrator. Just showing the disk utilization for the home folder. So I have just a few options here. All right, so let's see. U H. Okay. See. It's always a user error. There it is. Okay, it should be done in just a moment. All right, so finally completed. So let's go ahead and continue. Okay, perfect. So now it just displayed the disk utilization in the USR directory. So now it's all about locating the folder consuming the largest amount of space. So let's do this one here. All right, so now it's just displaying the disk utilization in the snap directory particularly. All right, so I'm gonna keep going just a bit more. Okay, perfect. So it just displayed again the disk utilization, particularly in the VAR log location. Again, it's all about locating the folder consuming the largest amount of space. But nonetheless, that's the end of that particular exercise. So now what I'm going to do is showcase how to stop a runaway process in Linux, right? So I'm just going to use the top and kill command to actually showcase this. So let's actually clear this out. All right, and then let's look at that's our top here. So it's just showing all the process IDs or the PIDs in the first column here. Um, but let's actually take a look at the system monitor. So let's see. Right. Uh, normally would normally show something else. That's fine. I wanted to do. Let's go back here. All right, perfect. So, so now what I'm going to do is click here, right? And then it's going to tell me what to kill. Let's say five. No such process. All right, I get the right numbers. All right, let's see. Let's see here. Actually, I know where. Let's see, system monitor here. Right. Perfect. One 17990. There it is. Perfect. So for the system monitor, that was the PID it was given the process. So I just killed the process with the ID number. Well, I tell it with the kill command, and then I tell it what process to kill with the PID, which is 17990 in this particular case. So it terminated the no system process. So the system monitor application, um, it won't appear for top in this search portal here because it doesn't exist anymore. I killed it. But nonetheless, just going to run another command here. Zip hash SDA. Right. Perfect. All right. So now that that's running, let's see. Put this over here. Okay. Let's see here. 29512. All right. Okay, perfect. All right, so let me go back to the first one. Let's see. It's not letting me exit the command. Oh, that's fine, because I already closed out the top um, command that it was executing. But nonetheless, that's how you ultimately stop a runaway and runaway process in Linux as far as killing it. So just for a brief recap, I went over managing processes in Linux. One of them was finding a runaway process. The other was stopping a runaway process. And I did it through a few different ways, identifying CPU performances, memory performances, disk performances, as well as identifying and killing a process as well. But nonetheless, again, this continues the long list of robust Linux capabilities for this Linux series. Can't wait to the next one where we're going over managing and configuring Linux system services. Can't wait to see you there. In the meantime, stay curious, stay secure.